Hello, my name is Maria Larsson. I will present our paper titled Tsugite'an, Interactive Design and Fabrication of Wood Joints. We propose a system to facilitate the creation of joinery, considering many practical criteria, including the material properties and machine restrictions. Let me start by showing a real-time interface demo. We focus on the design of a single joint connecting two or more pieces of timber. The design space is a 3D grid of voxels, and the joint is edited by pushing and pulling on the faces like this. Notice how this action is synchronized, so when I add a voxel here, for example, another one is removed here. The user can change the orientation of a timber by pulling on the body. The user can also set the sliding axis, the angle of intersection, and more things. You might already have noticed the colorful lines and fills that is appearing. This is real-time graphical feedback about the joint performance. So arrows at the end of each timber, for example, indicate the active sliding directions. So this timber, for instance, can slide out and up. But when I add a voxel here, it can slide out only. In case that a joint is invalid, suggestions are shown on the right side. There is also a so-called gallery mode in which the user can browse through pre-calculated valid joints that are produced by a combinatorial search. When a design is finished, you can press a button to instantly generate toolpath for fabrication with a 3-axis CNC milling machine. In summary, the user sets certain design requirements. Then the user can edit the joint manually by pushing and pulling on the faces while receiving real-time feedback and suggestions. Alternatively, the user selects a valid joint in the gallery mode. Finally, the joint is exported for fabrication. This is an overview of all the 8 evaluation metrics and with graphical feedback that we consider. These are practical criteria including connectivity, bridging, milling direction, checkerboard pattern, which is problematic for fabrication, slidability, which I showed in the interface demo, durability in regard to the fiber direction, contact area, friction area, and friction area. These metrics can be calculated in real time by analyzing the 3D matrix of integers, which is the underlying geometric representation. This is what the CNC milling looks like. This method of fabrication has the advantage that it is automated, it is very precise, and is also customizable. Now I will show some results of the joints that we have created with the Tsugite'an system. This is a high-resolution, high-friction eye joint in non-axial sliding direction. This is a non-orthogonal joint with a customized angle of intersection. And this is a 3-timber joint. To show the usefulness of the system, we also fabricated a real-sized chair that a person can sit on, and a table. As for limitations in future work, due to the voxelized geometric representation, it is not possible to make, for example, a dovetail joint or some freeform shape. It is also not possible to create multi-timber joints that have more than one sliding axis. And the system is made for frame structures. It does not fully extend to plate-to-plate connections. Thank you so much for listening. Please read the paper for more technical details and results. I'm very excited to hear your comments and questions. Thank you.